All right, these notes are over nuclear chemistry. So radioactivity, one of the pieces of evidence for the fact that atoms are made up of smaller particles came from the work of Marie Curie. She discovered radioactivity, which is the spontaneous disintegration of some elements into smaller pieces, or radioactive decay. So there's 3 types. Alpha emission is the first one. You're going to have your alpha particle is what's lost in the reaction. So these are your reactants on the left-hand side, and then your product. So you'll get an alpha particle as a product. And really an alpha particle is just a helium atom. Then we have beta emission, and the beta particle is an electron. So you lose an electron with beta emission. Positron emission, it's the same thing as a beta particle, except if you notice it's positive. So they call it a positron, because a proton becomes a neutron. It stays in the nucleus, but then a positively charged electron and energy is released. Electron capture, this is another beta particle, except this time it's colliding with an element, and the electron combines with a proton to form a neutron. So it still changes elements, except just this time it's capturing it. Then we have gamma emissions. And the gamma emission is just a photon. It's just pure energy. All right, so alpha particles are very heavy. They have a high mass. It's a helium atom, and they can be stopped with a sheet of paper. This is paper. Beta particles have a little more energy, but they can be stopped with wood. Gamma, though, has very high energy, and that has to be stopped with lead. That's why they make you wear a lead vest when they do x-rays, because of high energy. All right, nuclear reactions involve changes in the nucleus, whereas chemical reactions involve the loss or gain of electrons. So different isotopes of the same element may undergo very different nuclear reactions, even though an element's isotopes all share the same characteristics. Okay, so these are the types of nuclear equations that y'all need to know. Alpha emission, again, you know it's an alpha emission because of the helium atom. That's an alpha particle. Beta emission, you have a negatively charged electron. Positron emission, positively charged electron. And electron capture, the electron is on the reactant side. So here's some general reactions that you can remember. Alpha emission, I'm going to subtract 2 from my protons. Beta emission, I'm going to add 1. Positron, I subtract 1. Electron capture. Okay, so when you're balancing nuclear equations, you have to make sure your mass number balances and your atomic numbers balance. So it's just subtraction. You have to look at both sides of the arrow. So 218 has to balance out this side. So something plus 4 equals 218. So that would be 214 up here. And then 84, something over here on this side, something plus 2 has to equal 84, so 82. So then what element is that? What element is 82? It is, I can't see that far away. Lead. Oh, it's lead. So lead. Okay. So here I'm going to make sure find my arrow. This side has to equal the product side. This is a neutrino particle right here. It's just a neutron. They still have to balance out. So over here, total 27 plus 4, 32, nope. 31 is my total mass number, and down here 15 is my total atomic number. So on this side, it needs plus 0, so 15, and then 31, something plus 31, so 30. And identify elements with the atomic number, that's phosphorus. Okay, so 206, find your arrow, 206 plus 4 is 210. 82 plus 2 is 84, I feel like we just did this one. And 84 is polonium. Okay. 14 This has to equal this still has to equal 6, so this is 7, and that's nitrogen. 7 minus 1 is 6. Calcium, so this is 0, and 20 minus 1 equals 19, so this is an electron. That's a beta particle. All right, here's some uses for radioactive nuclides. So you don't always have to be, frightened of radioactive things, okay? So cancer, they have radiation treatment that helps, computer imaging techniques, radiocarbon dating, smoke detectors detect radiation, food irradiation, it preserves the food longer so that people can eat. The food is traveling many distances from the farm, and if they didn't irradiate it, bacteria would grow. And then radioactive tracers, and this is like bio, where they can track molecules through your body. Nuclear fission. Okay, so fission is when they split apart into smaller molecules. So you start out with something like uranium, a fast-moving neutron hits it, and it splits it in half, and it's tons and tons of energy. And this is what happens in a bomb or in a power plant, nuclear power plant. They're making energy. And so in a bomb, it's just an uncontrolled reaction. In a power plant, they control it. So here's this chain reaction. It takes this one little neutron, bam, right into that nucleus, and it splits, and it also releases neutrons, which splits and releases neutrons, and splits and releases neutrons. And it just keeps going and going and going and going. Fusion is where two lighter nuclei combine to form a heavier nucleus. This is what happens in the sun. All right, try these, and we'll go over them in class.